In this section, we're talking about trig functions of general angles. In the last section, we looked at those trig functions just of acute angles, meaning that every one of the angles before was in quadrant 1. Now, we're keeping our angles in standard position. Remember, initial side along the positive x-axis, vertex at the origin, but now the terminal side of the angle can be anywhere in the coordinate plane. What you'll notice is that these ratios don't change, no matter what. The sine of theta is still going to be your y distance divided by your r distance. But now, one of the things you have to pay attention to is that the x value is negative. So that means that all of our trig functions could be negative values depending on which functions we're looking at. The sign of the trig function depends on the x and y values of that point P on the terminal side of the angle. Remember that the r distance is always going to be positive. We use an acronym, all students take calculus, to help us identify whether or not the trig functions are positive or negative. You always start in quadrant 1. So quadrant 1 is all. That means all trig functions are going to be positive if the angle is a quadrant 1 angle. This should make sense because that's what we were looking at in the last section, and all of those functions were positive. The next is students, quadrant 2. Students means sine, but you have to remember that sine has an inverse function, and that inverse function is cosecant. So here I said sine and its reciprocal are positive. So S for sine. The third one is take. All students take. Take stands for tangent. Again, we need the reciprocal function of cotangent. And then the final C is for calculus, and that is for cosine and its reciprocal are positive. So if you always think of it in that way, all students take calculus, then regardless of the location of the terminal side of the angle, you will know whether the trig function is positive or negative. The angle that I just showed, sine is going to be positive, cosine will be negative, tangent will be negative, cosecant will be positive, secant will be negative, and cotangent will be negative. When working with general angles, we also need to consider the reference angle. As the definition above states, it's an angle that's created by the terminal side of an angle in standard position and the x-axis. Now this can go in any direction. So if the angle were here in quadrant 4, the reference angle would be in this direction. From the reference angle, we also can derive the reference triangle. Reference triangle is the triangle you create from the reference angle. So we have this point P that we have identified along the terminal side of our angle. When we draw a vertical line from point P to the x-axis, we create a right triangle. The acute angle that's made, the reference angle being alpha, is the angle that we can use trig functions from. We have our x value and our y value. The reason that these are absolute value symbols is because we know they can be either positive or negative because distances are always positive. Now remember, because we're dealing with angles in different quadrants, the x-coordinate and y-coordinate can certainly be negative, which will change the sign of a lot of our trig ratios. Here's the first example. We have an angle in standard position, and its terminal side passes through -3, -4. Find the values of the 6 trig functions of theta. Well, that's pretty simple. We always know the first thing we need to do is calculate the value of r, and that is the square root of -3 squared plus -4 squared, which means that that would be 25, so r is equal to 5. From here, we need to think about the location of this point. You may want to sketch yourself coordinate axis. We know that this is at -3, -4. So this particular angle is a quadrant 3 angle. We can look at our reference triangle if we need to. We don't know this angle alpha, but we do know that our x distance we can call -3 and the y is -4, r is 5. So if we start taking the sine of theta, well, we know sine is y over r, so that's -4 over 5. Cosine, x over r, so -3 over 5. Tangent, y over x, -4 over -3, which we can then reduce to be 4/3. Cosecant, -5/4. Remember, we always move our negative sign to the numerator. Secant, -3/5. And then cotangent is 3/4. If we use our acronym, all students take calculus. All students take calculus. My terminal side is in the third quadrant, which is T. That means that tangent and its reciprocal are the ones that are positive, and they both are. Here we're asked to determine which functions are defined for a 90-degree angle and to find their values. Remember that a 90-degree angle is a quadrantal angle. There's my coordinate plane. Here's my initial side, my terminal side. I can select any point P on here. So if I select that point to be 0, 1, the R value would be the distance from the origin to my point. So R is equal to 1. So when I start with sine of 90, because that's the angle that I know, sine of 90 is y over r, 1 over 1, which is 1. Cosine is x over r. 0 over 1 is 0. Tangent of 90 is y over x. This is undefined. You cannot divide by 0. Cosecant is the reciprocal, so that's 1. Secant, again, this is undefined. And then tangent, I'm sorry, not tangent, cotangent is 0. In this example, we're asked to write the sine of 130 as a function of an acute angle. What they want is a reference angle. So I would always start with sketching this in the coordinate plane. My initial side is along the x-axis. 130 degrees is somewhere in between 90 and 180. It doesn't have to be exact, but you have to know that it's somewhere in here. This is 130 degrees. So when I'm looking at the reference angle, I'm going from the terminal side to the x-axis. So I'm now looking for the difference between the next quadrantal angle, in this case 180, and the degree of theta. In this case, it's 50 degrees. So I would write that it's the sine of 50 degrees, but I do have to remember, all students take calculus, to make sure that I have the proper sign, S-I-G-N, on this sine function. In this case, it's going to be positive, so I can leave it the way that it is. Finding the exact value of tangent of 135 is relatively simple because really we could just plug it into our calculators. But on a problem like this, we can also think of it in terms of reference angles. Here's my coordinate plane. My initial side, 135 degrees, is somewhere in the second quadrant. I can look at the reference angle here, which is 180 minus 135, which gives me 45 degrees. Well, knowing tangent of 45 degrees is something that we are expected to know, and it's 1. That's simple enough. However, we still need to remember all students take calculus. This is a second quadrant angle. So the only functions that are going to be positive are sine and cosecant. Tangent isn't positive till quadrant 3. So for this particular angle, the tangent is actually negative. So it's -1. Here we're asked to find the 5 other trig functions of theta if we know that the sine of theta is -3/4 and theta falls between 180 degrees and 270 degrees. If I sketch this out, I can see that my angle is a third quadrant angle, which means that if we look at all students take calculus, tangent will be positive. Everything else will be negative. To start this problem, we'll use the Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. I replace sine squared of theta with -3/4, and I square it. Cosine squared of theta stays the same, as does the part where it equals 1. When I square -3/4, I get 9/16. I can then subtract 9/16 from both sides of the equation. And then I take the square root of both sides. Now remember, when you take a square root, your answer can be positive or negative. Knowing that this is a third quadrant angle, knowing that only tangent is positive, that tells me that this cosine is negative. So I can write that down, that the cosine of theta is -7/4. Now I can use my quotient identities to say that the tangent is equal to the sine of theta over the cosine of theta. So that's negative 3/4 divided by negative square root of 7/4. If we copy dot flop, we end up with 3 over the square root of 7. But remember, we're not allowed to have that radical in the denominator, so we can multiply by the square root of 7 over the square root of 7 to get 3 square roots of 7 over 7. So that's going to be the tangent. We know sine, which means we can very easily get the cosecant of theta to be negative 4/3. We know the cosine, which means that secant of theta is negative 4 over the square root of 7. When we rationalize that denominator, we end up with negative 4 square root of 7 over 7. And because we have the tangent, we can very easily say that the cotangent is the square root of 7 over 3. Notice cosecant is negative because sine is negative. Cosine is negative, secant is negative. Tangent is positive, cotangent is positive because of the location on the coordinate plane.